G'day, Internet. Nice to meet you again. Yeah, that was just the day 9 for Advent of code that my Commodore printer was printing out, so let me get that one ripped out from the printer. And let's adjust the volume a little bit. Okay, so there's a lot of text this time, it looks like, and a lot of numbers. Okay, so here all the way. Yeah, yesterday's problem was quite computationally involved. I solved the first part on video, and the second part I solved offline on PC, and then only later figured out a way. So on PC I got the runtime down to less than a second, but that would be way too slow for the C64. So I initially wasn't able to solve that on the Commodore, but then later on found out a way after browsing the subreddit. So there was a critical tip, and I then coded up an implementation that you can find in my blog. That did run on the C64, and it took about 2 minutes to execute. So yeah, so I did get eventually the second part running on C64, but needed a little bit of a tip from the community. Cool. Okay, so now it's day 9, and today we have Mirage maintenance. Okay, so how does the story go? You ride the camel through the sandstorm and stop where the ghost's maps told you to stop. The sandstorm subsequently subsides, somehow seeing you standing at an oasis. Okay. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be yet another giant floating island. This one made of metal. That must be where the parts to fix the sand machines come from. So wait, we want to get snow, but in order to get snow, we need to get sand, and in order to sand, we need to fix the parts from the metal island. Yeah, I can kind of see where this is going. So in order to get the metal, I think we still have time to get more hurdles in. Okay. There's even a hang glider partially buried in the sand there. Once the sun rises and heats up the sand, you might be able to use the glider and the hot air to get all the way up to the metal island. While you wait for the sun to rise, you admire the oasis hidden here in the middle of desert island. It must have a delicate ecosystem. You might as well take some ecological readings while you wait. Yeah, of course. Maybe you can report any environmental instabilities you find to someone, so the oasis can be around for the next sandstorm-worn traveler. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they're changing over time, your puzzle input. Each line in the report contains the history of a single value. The history of a single value, okay. For example, okay, so there's 3 lines of code. So this is the puzzle input, okay. To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the difference at each step of your history. Differences at each step of your history. So is this like 3, 3. Oh, this is all 3. 3, 3, 3, 3, 3. If that sequence is not all zeros, repeat this process using the sequence you just generated as the input. So it was 3, 3, 3, 3. So that would be all zeros, 0, 0, 0, 0, 0, 0. Once all the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. In the above dataset, the first history is 0, 3, 6, 9, 12, 15. Yep. Because the values increase by 3 each step. Okay, so it will be a 3, 3, 3, 3. Note that this sequence has one fewer value than the input sequence because at each step it considers 2 numbers from the input. Since these values aren't all 0, repeat the process. The values differ by 0 at each step. So the next equal, okay, so exactly. This means you have enough information to extrapolate the history. Visually, these sequences can be arranged like this. That looks like a Pascal triangle. You get like differences every step. To extrapolate, start by adding a new 0 to the end of your list of zeros. New 0 to the end of list of zeros. So here, because the zeros represent differences between the two values above them, this also means there's no placeholder in every sequence above it. Oh yeah, so here's a star and a 0, so we added a new 0. And then there's A and B. You can then start filling in placeholders from the bottom up. A needs to be the result of increasing 3, the value to its left, by 0, the value below it. This means A must be 3. Okay, yeah, so A is gonna be 3 plus 0. A must be 3, yeah. Finally, you can fill in B, which needs to be the result of increasing 15, the value that is left by 3, the value below it. Or 18. 15 plus 3 is 18. Yeah. So the next value of the first history is 18. Finding all 0 differences for the second history requires additional sequence. Okay, yeah, so now we're going to the second input, so that's like 1, 3, 6, 10, 15, 21. Right? Yeah, wait. Yeah, 1, 3, 6, 10, 15, 21. So these are triangle numbers. 2, 3, 4, 5, 6, 1, 1, 1, 1, 0, 0, 0. Then following the same process before, work out the next value in each sequence from the bottom up. So we added 0, yeah. And then this one is 1 plus 0, yeah. And then this one is 6 plus 1, and then 21 plus, yeah. So the next value of the second history is 28. The third history requires even more sequences, but its next value can be found the same way. Yes. So the next value of the third history is 68. If you find the next value for each history in this example, add them together, you get 114. Analyze your Oasis report and extrapolate the next value for each history. What is the sum of these extrapolated values? Oh, I see. Okay. Yeah. So if I have a puzzle input line, let's say here the worst case. This one is initially, it's 6 lines, 6 numbers of input. So I have six initial numbers. Then I need to generate 5 new numbers. And then 4 numbers, and then 3 numbers, then 2, up until this becomes zeros. So, yeah, so this is gonna be n plus 1 over 2. Yeah, so this is gonna be quadratic. Do I wanna generate? So it's gonna be quadratic space and quadratic time if I do this naively by generating all these lines and accumulating this. Do I want to do that? How long are these lines at maximum? Get your puzzle in. Okay, so I think the first thing I want to do is to figure out how long these lines are. That will this quadratic space and time like solution, will this ever finish, or is this something that is gonna be just doomed from the start? Okay, let's do that. So let's go here, and now what I want to do is save the example input. So this is my example input. Save to device 9 2023.example9.txt. Okay. And then Shift I 2023.input9.txt. Oh, there are some negative numbers as well. Alright. Well, maybe there's negative numbers. I'm not quite sure why there is a minus, but we'll see. A lot of numbers. This seems like a big input. So what I'm printing here is actually not all the input numbers, but I'm basically subsampling all of these numbers, because if I would print all of them on screen, that would slow down the disk writing. So that's why some of these numbers don't really look. Okay, so I didn't have enough memory even to store the puzzle input. So yeah, okay. Okay, let's get started. So what I want to do is actually print a couple of lines and calculate how many numbers do I have in the input to start, or how many numbers per line do I have. File F. So this is the usual mantra by now. 2023.example, or let's open the example just to 9R. So read from device 9. And then char line, let's do 200 characters. While F gets So yeah, let's print out the input. That's a good start. So device 9 2023.9a CPP. Okay. Oh, and my server is already down. Okay, so let's reopen. 9 CPP. Okay, so now running this. So those are the example input. Okay, so yeah, there were 6 numbers in those. But what about the actual inputs? That is a lot of lines. But not that many numbers, so that's like 2. Okay, let me wait until this finishes. That's a lot of input lines though. Okay, this might be reading a while. But there's like maybe 20 numbers per line. So a quadratic per 20 lines would be 400. Is there a smarter way? So if I had 20, that squared is 400. Okay, so what do I have in the last sub? That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. Okay. Okay, let's try the quadratic solution first. So I need to parse these numbers. Let's say, and those were pretty long, so I need to use U32 for those. Numbers. Let's say we have 24 maximum. Int n equals 0. Oh, no. Int n equals 0. That goes here. And then we get char s equals string while star. Number n plus plus equals atoll. ASCII too long. Atoll of the string. While is digit star plus plus s. While star greater than 0 and while star and not a digit digit star plus plus s. printf number n minus 1. Okay, so let's see. So this is the first line. Save this. Do I successfully parse the first line? Yeah, I do. So 6 numbers. So the last one is the number of numbers, and the first numbers are the numbers. Okay. And let me do this again. Yeah, okay, so this is gonna take a little while to run, but I need to know. Oh, 21. Do not take this break away. So what is the maximum number of numbers? So we get 22s in there. There's 21s. Most of them are 21. Oh, they were negative numbers. I'm parsing to a U32. Actually, that's a mistake. But now I'm kind of skeptical why some of those have 22 and some of those have 21. Like, is that a bug of mine, or is that just how the problem input is? So let's debug that quickly. So this has to be I32. Isn't LD? If n equals 22, right? Okay, so double check on this. Wait, something doesn't seem quite right. My input line is -3, 9, 34. What is happening? Okay, so so it seems like we'll do this to get the screen. So it seems like I don't, well, first of all, my atoll function is not properly parsing the negative numbers, except for the first one. And then I get this twice. Like, what the heck? Let's add this one. Okay, so good thing I checked, because I certainly have... Okay, so it's not happening on the first line. Okay, so a couple. I just want to see that that one with the negatives. Total 21. But wait, why is this now? Wait. No, I'm getting a little bit confused here. Printf line. Okay. Okay, so now, yeah. So the second to last line, 2 minus 1 minus 1. So I'm getting this unsigned, or oh, no, I'm scanning. Yeah. No, no, that's my... Okay, so this was my bug, of course. I didn't handle while s equals minus or... Of course. And... is not minus. Not. Okay. So are all the inputs after all 21 lines? They probably are. Yeah, now I'm getting the negatives right. Okay. So I was blaming HOL completely incorrectly, and of course it was my string advancing that was the problem here. So... now I get to do this all again. So all the inputs have 21 numbers, that's my assumption. Yes, indeed. But there are so many of them. So I'm thinking that there maybe is some kind of faster solution that I could maybe wind up these differences instead of creating every row of them. And then I could have, maybe that would give a linear solution. What happens if I press restore in the middle of... Okay. Okay, well that finished. So... yeah, let's think about this for a moment. Let's think about this for a moment. So... let's get some paper here. I am thinking that... okay, so we have these input numbers. How would I do this? So let's say how I have input numbers. I'm gonna draw these like A1, A2, A3. Let's do A4. So I have 4 input numbers. I'm gonna draw them from right to left because so basically I am looking for what is A0. And I was asked to calculate the differences, so A1 minus A2, so that would become in between here, and then, but let me do, so let me visualize this a little bit differently, because what I want to do is add this minus this, but I'm gonna build a triangle like this way, because then it's gonna mentally map to my indexing. So let's say this is A1 prime, A2 prime, A3 prime, and then this is A1 prime prime, A2 prime prime, and this is A1 prime prime prime, and A0 prime, A0 prime prime, A0 prime prime prime, and A0 4 prime. So this is gonna be 0 by necessity, I think. Or not necessarily, I don't know. But let's assume this is 0. Like we had a full triangle. Maybe this becomes out to be a 0. Oh no, this is the number that we create. No, this is always 0 because this is the number that we add. And then we have this equality that A1 prime is equal to A1 minus A2. So this equals this minus this. And then A1 prime prime is this minus this. So that's A1 prime minus A2 prime. Which is, so expanding this is A1 minus A2 minus A2 prime. What is A2 prime? A2 prime is this minus this, so that's A1 minus A2 minus A2 minus A3. So that's A1 minus 2A2 minus A3. Okay, so I can also already spot a pattern. This is like Pascal's triangle 1, 2, 1. Oh, but I did a mistake. This is a plus. Minus, minus. So this is like a Pascal triangle 1, 2, 1. But here's a minus. So A1 prime prime equals this. So what is A1 triple prime? A1 triple prime is A1 double minus A2 double, which is, so now I can read this, which is A1 minus 2A2 plus A3 minus, what is A2 double prime? So that's of course the same thing, but I just moved the indexes one place. So right, yeah, I just moved the indexes one place. So this is A2 minus 2A3 plus A4. So I get A1 triple prime is A1 minus 3, yep, 3A2 plus 3A3 minus a4. So 1, 3, 3, 1. So that is like the Pascal triangle, but plus minus plus minus. Okay, so now I know what all of these are. So what are my values here? So this A04 prime is 0. Then A0 triple prime is this plus this. So this is also A0 triple prime. Not triple, triple prime. And then A0 double prime is this whole thing plus so wait, so I have this and I have this identity and then I have this identity. So A0 double prime is this thing plus this thing. What is that? So we have 2A1 minus 5A2 plus 5. Wait. So A0 double prime equals A0 triple prime plus A1 double prime. So that's 2A1 minus 5A2 plus 4A3 minus A4. Okay. And then A0 prime equals this plus this. So that would be 3A1 minus 6A2 plus 4A3 minus A4. Huh. Okay. I was kind of expecting that this would also be a Pascal triangle thing. But now I'm starting to feel like I would have done a mistake somewhere. I can't quite spot it. Yeah. So my thinking was that I would have a formula. Oh, actually, so this is a0 prime, so the final answer would be a0 equals this one plus a1, so 4a1 minus 6a2 plus 4a3 minus a4. Oh, but this is a... This is a Pascal triangle thing. 1, 1, 4, 6, 4, 1. Yeah. Wait. So that is like if I move this identity over this side, so I get like minus a0 plus 4a1 minus 6a2 plus 4a3 minus 4a4 equals 0. So that's like the full Pascal triangle, but with just like alternating minus plus minus plus minus. Okay, so what does this mean? So this means that because I have such a lot of input numbers that are all like 21 numbers, what I can do is create a Pascal triangle for 21. And they use those cofactors to multiply the input number. So here's my, like the final answer in terms of just the input numbers. So if I do Pascal triangle on level 21, that's gonna be a quadratic enumeration. But I only need to do it once, and there were like 100 input lines. Okay, well, let me try first generating Pascal triangle 21 lines deep. That's... Or do I need to do 24 lines? So I had 4 input numbers. So I needed like 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Yeah, 4 input numbers, so I need like 1, 2, 3, 4, 5 levels. Okay. Oh, I had the whole thing on the side. Well, let me put this on just for a second. So here's the final thing. Sorry it was so small all this time, but yeah. So now I'm coding. So I'm going to do U32 Pascal 21 times, well, define P21. P squared. Actually, let's do this just P and then 1 Pascal. Okay, so int level equals 1. So Pascal 0 is this one. And Pascal I'm just gonna do this like this. Y times 21 plus x. So Pascal at... So if I'm indexing This is like at 0, 0. Then 1, 0 equals 1. And then also P at, or actually, let's do it this way. And I'm going to put that all the way here. Yeah, this is nicer. So I can now do P 0, 0, P 0, 1, P 1, 1 equal all 1. Yeah, that looks clean. Expected expression. Wait, what? Why is it complaining? Oh. Compiler crash. Oh, still not working. Interesting. The compiler is not, or it's crashing on this. Oh. Yeah, seems like the compiler is crashing on this input. Okay, so now it might be. Yeah, now it's doing its thing. Cool. So level equals, so I have now level 0 and level 1. So level equals 2, level smaller than size, plus level, or let's do y. And then for int x equals 0, x is smaller than so level 0 has 1 entry, level 1 has 2 entries, so x is smaller than y plus y 1. So if I'm at level 0, I have 1 entry. Oh, 1 entry. At 0. Level 1, I have 0 and 1, so 2 entries. Yeah. Plus x. And p y x equals p y minus 1x. How am I lining this up? Oh, I want a sentinel. I don't want to do... Well, maybe I am going to do. Well, let's do like this. So this general formula would be Py minus 1x plus Py minus 1x minus 1. But the thing is that here x is out of bounds. So actually I need to do from x from 1 and Py 0 equals 1. Is this now correct? So let me redraw my Pascal triangle. So I'm indexing like 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4. So P at yx, or let's do this, P at yx equals y minus 1x plus y minus 1x minus 1. Yeah, so it's always one top and one to the left in this kind of linearized. And this one comes automatically. Yeah, so looks like this indexing should be fine. And now let's print it out. For int y is 0, y is smaller than size, plus y. For int x is 0, x is smaller or equal than y, plus x. Printf Pascal at yx and a new line. Okay, so that's a Pascal triangle. So generate a Pascal triangle equals 0. Okay, so let's run. Oh, I added a new line. Why did I add a new line? Well, those are some pretty big numbers. Okay, so this should be a... yeah, let's do a break here. 1, 1, 1, 1, 2, 1, 3, 3, 1. Yep. Perfect, okay, and the rest are probably gonna be right. Cool. So that's a Pascal triangle. You can go away now. And we needed to sum. What was the thing? Okay, sum of oasis. So I'm gonna do oasis equals 0. And now I get all these inputs. Now I should be able to just calculate. So new entry equals 0. For int I equals 0, I is smaller than n, plus I. Okay, so now I need some really good indexing. So it's gonna be like entry Oh, but it's gonna alternate. It's gonna alternate. So no, if it's gonna go. So it's gonna be plus minus plus minus. Okay, so I plus equals 2. Small I plus 1 is smaller than n. I plus 2. Yeah. And then I have entry I plus equals Pascal at how many numbers do we have? That's the level. Minus 1. Wait, so, okay, let's double check. So, here I had 4 input numbers. And I wanted to get level 0, 1, 2, 3, 4. No. Okay, so that is P of n. And what is x? X starts at... So this thing is always symmetric. So x can be I times the input number, which is num of I. And then minus Pascal n of I plus 1. No, now I'm doing something wrong because num n minus 1 minus I. So I'm coming from right to left times num n minus 1 minus I minus 1. Ooh, is that correct? Entry I, what is I here? And then we need the leftover. We need the leftover, so the leftover is if n is odd. So I've added even numbers, plus, minus, plus, minus. So I need to add entry plus equals. So there might be that leftover thing. Entry plus equals P of n minus 1 for n. So I equals n minus 1. No, I equals 0. Or oh, it's just gonna be 1. Yeah, it's just gonna be 1. So I'm gonna be adding number 0. Okay. That's gonna be a miracle if that works from the first try. That's quite some index gymnastics there. So let me see. Okay, let me say first. I do want to print 4. Now this I is debug leftover. Int I equals 0, I is smaller than n plus I. LD, so I'm adding this back. Num of I. Yeah. Oasis plus equals entry. Oasis yeah, we'll see what happens. Was I on the... No, I was on the input. Let's go to the example. I'm not printing anything. Because I was just generating Pascal and returning. Three, 0, minus 5. Well, that's not correct. Well, it is... Wait, okay, so... Let's deep debug this. So... So I'm gonna do plus LD times LD, which is this thing. Okay, and then yep, and then minus, which is this thing. And then, oh, that's a comma. And then here I have F plus leftover okay. Undeclared I. Declared I. Oh, okay, so yeah, now my compiler is also acting up. Okay. What happens with this? So those are the input numbers or Pascal triangle numbers on the left. And then the input numbers from right to left on the right. So what was my input? Yeah, 0, 3, 6, 9, 12, 15. and then 136. So indexing is right on those 10, 13 on the input numbers. So those come right, but wait, is that 1, 5, 10, 10, 5, 1? Yep, 1, 6, 15, 20, 15, 6, 1. 1, 6, 15, 20, 15, 6, 1. Yeah, that's also right. So I'm calculating, so my indexing is correct on the Pascal triangles, my indexing is correct on so that means that my mathematics seems to be wrong. Well, let's double check. A must be 3. So I got the first one right. Wait, I've calculated entry 3. 21. Yeah, my mathematics must be wrong because I'm calculating exactly what I anticipated to calculate. 12, 15. Let's double check. Oh no, actually, no. I am not calculating what I intended to calculate. Sorry, no. Because I want to calculate. Yeah, okay, now I see what's the issue is. So I intend to calculate here that my new number is Pascal triangle. Like here, I don't start with 1, 4, 6, 4, 1, but I skip the 1 and I go 4 times the first number minus 6 times the second. So here I do plus 1 times 15. So I'm 1 to the left. So I'm indexing 1 to the left. So plus 1 plus 2 plus 1 plus 2. What do I get with this? $18, 28, and 68. Is that anywhere close? 18, 28, and 6. Yes, now it's okay. Now it's the correct answer. Oasis value is 114. Okay, if you example add them. Okay, so this is now correct. Okay, now this is getting exciting. Perfect. So now I can drop my debugging. Yeah, let's drop all of that and let's just go for it. Actually, I'm worried that if these numbers get large, that this could go past this, but input 9, so okay, let's save that. And now we get to the moment of truth. All this work, live 1 hour and 13 minutes. So 1 hour for the first attempt. Oh, I should probably print it at least some info. Now it's gonna run on an empty screen and spit out the answer. the tension is building up. Is that gonna be right? Or not? Oh, now I actually think maybe I should have generated one more, like my Pascal triangle. Yeah, this might come actually all zeros, because I might have off by 1 on the size of my Pascal triangle. I only generated up to level, like 21 levels up to level. Oh. No, I'm getting a negative value. Why would I get a negative value? Well, I mean, it could be right. But that's kind of disheartening to have a negative value. Minus 299, 586, 268. Yeah, that's kind of disheartening because, okay, so let's double check. So I have 21 numbers. So I'm accessing P21. And here I put size 21. Yeah, so yeah, that's exactly right. So I need to have size 22 here. Let's print all the entries. So this was basically printing only those leftovers and nothing else. Okay, so yeah, now they look mostly positive, and that's what I would expect because there were only very few negatives. Although these numbers, yeah. So I really wonder what this algorithm is extrapolating, because the interesting thing was that I think in the first one, see in the example, the first example is like constant additions, and we get the constant addition next. And the second example is triangle numbers, and this computes the next triangle number. So I'm curious, like if I put in here cube numbers, if this is going to extrapolate the next cube number. Are these cube numbers? No, they are not. Okay, so now I get a result that looks like something interesting. Hold on. I may have overflowed. Okay, so this might have overflowed. 1842168 671 1842168 671. Because these values are pretty large as well. Okay, so before I submit, I do want to give this a double check. If I might have overflowed 32-bit integer. Actually, now that I think, those are like tens of millions. So I'd have to have about 100 of them to overflow. Well, there might be just be 100 inputs, I don't know. that's pretty close to the I-32 limit, so. No, I do get the same number. Okay, 184216867 yes. Okay. So let's go check that out. Day 9. Submit the answer. 1842 168 671. Oh, yep. Nice. First try. That was the right answer. Cool. Okay. So what kind of stuff do we have in part 2? Okay, so I'm going to tap on P to get the print mode, and then I'm going to select this one, and then let's take it to the printer. Okay, so that wasn't too much text at least. Oh. Okay, so part 2. Of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding differences until the sequence of differences is entirely 0. So the same thing. Then rather than adding a 0 to the end and filling the next values of each previous sequence, you instead add a 0 to the beginning of your sequence of zeros, then filling the new first values for each previous sequence. In particular, here's what the third example history looks like when extrapolating back in time. Adding the values on the left side of each sequence from bottom to top eventually reveals the new leftmost history value of 5. Doing this for the remaining example dates above results in previous values of -3 for first history and 0 for the second history. Adding all of them produces 2. So, where is it? Okay, in here. So, adding in new values in the left side for this example. So this is the last example. So this gives 5 here. And this one gets -3. And where is it? 0 for the second history. and all of them together equals 2. Okay, so we do the process. We do the process to the left. Where's my stuff? So this time, so now if I'm thinking about my triangle here, I'm instead like going for going for this kind of triangle. So A4, if I had the same thing, A2, 3, A2, A1 as before as the inputs, and then A3 prime, A2 prime, A1 prime, A2 prime prime, A1 prime prime, and then A1 triple prime. Instead of adding things here, I'm basically adding a 0 here and then calculating values in here, and this is the ask value. That's basically what's happening here. Right? Yeah, I think that's the case. So okay, so let's call this. Well, I don't want to change my indexing, so I do need to call this A2 triple prime, A3 double prime, A4 prime, and A5. So I have 0 is this minus this. So I get A2 triple prime equals A1 triple prime. And then I have A2 prime equals A2 triple prime plus A3 double prime. Okay, this this notation is pretty convoluted for this task, but I think it should be enough. So basically I get A3 double prime equals A2 double prime minus A2 triple prime. Yeah, so this value is basically this minus this.
Okay. And this one was, okay, so these primes aren't the best notation here, but plus A1 triple prime. Minus this, so A4 prime equals A3 minus A3 prime. So this one is this minus this, which is A2 double prime plus A1 triple prime minus A3 prime. So it's A2 double prime plus A1 triple prime minus A3 prime. So this one is this plus this plus minus this. Okay, that makes sense. And then A5 equals, which way around was it? Actually, so yeah, so A5 equals A4 prime minus A4. A3 double prime was A2. Oh, the other way around. Minus plus. Oh yeah, my notation is kind of confusing here, but I think I I got it. So this means that A5 equals oh wait, did I know? Well, let's see, A4 minus A2 double prime plus minus A1 triple prime plus A3 prime. So A5 would be A4 minus A2 double prime minus A1 plus. Okay, now I must have confused something. Now I must have confused something. Okay, so double checking time. So actually I need a mnemonic. So when I have X, Y, Z here, then X is Y plus Z. So this one is always the one below plus the one to the right. So then the one on the left, Z equals X minus Y. So this one is this minus this. So let's try this again. A5 equals, so Z equals this minus this. So A5 equals A4 minus minus A4 minus this, which is this minus this. A3 prime minus this, which is double prime minus this, which is equal to A1 triple prime. So this is A4 minus A3 prime plus A2 double prime minus A1 triple prime. A4 minus, so I did do a sign mistake here, plus A2 minus A1. Okay, so I did have a sign mistake. I trust my mnemonic here more. And then I need to now expand out here. Again, these how do I get these numbers? Oh, but I don't have formulas for these. Oh crap. Well, let's expand it manually. So what I want to do is kind of like get to this Pascal triangle formula, so I can see what the kind of like the general rule would be. That's my goal here. So A3 prime. So y is x minus c. So y is x minus c. So this one is this minus this. So A3 is this minus this. So this is A3 minus A4 plus A2 double prime is, maybe I'll just go through this. This is a slightly different derivation, but, and then minus this one, A1 double prime minus A2. Okay, A4 minus A3 plus A4, 2A4 plus A2 prime is A2 minus A3 minus A3 prime is A3 minus A4 oh, this is getting convoluted, but A2 prime or A1 prime is minus A2 prime. This one gets a plus A2 prime minus A3 prime. So here I get 2A4, here's a 3A4. And then I get a minus 2A3. Minus 3A3. 1, 2, 3. And then I have a plus A2. A1 prime minus A1 prime is A1 minus A2 plus A2 prime is A2 minus A3 plus A2 prime. Well, I should have added this up. Now I'm doing this minus. Yeah, this wasn't the sharpest derivation, but I'm hoping that I'm gonna get to the result here. And this should be it. So yeah, 3 4 A4 A3 here, A3 here, 3 4 5 6 minus 6 A3. Then A2 is 1 2 3 4 plus 4A2, and then A1 is 1A1. So wait, it's the same. So A5 equals so where's my previous formula? My previous formula was in here. So it's the same thing, just in other
Okay. Same thing, same thing. So let me save this first. Same thing, but from the different direction. Oh, and of course, because I mean that makes so much sense, because Pascal triangle is symmetric after all. So you're like horizontally mirroring this thing, so you're computing the same thing from a different direction. Yeah. So here my numbers are just I and I plus 1. And this is gonna be n minus 1. Minus 3, 0, and 5. Minus 3, 0, and 5. Yeah, that checks out. Oh my god. So I did like half an hour of derivation to understand this thing is mirrored. Where did I do? Yeah, minus 305 equals 2. Okay. Nice. Nice. Okay, so now run on the input and get the result. Yeah, and this was such a brute force calculation or derivation in general, like no smarts whatsoever. Because I wanted to reuse my notation from before so that I was able to like correlate that to the previous indices. Oh, but what is going on? No, something is not quite. Oh, no. No, it is, because those initial values do need to be small. Up. Sorry about that. Yeah, so this is getting very small values, but those initial values do need to be small, because it is a growing sequence after all. So I do have faith that this might be correct. So this is 903. 903. So let's go have a peek. Answer 903. Yep. Cool. Okay, so 1 hour and 45 minutes. Oh, Stalma. Let's go admire our stars. 9 stars. Or 9 days, 18 stars. And there is some kind of island here as well. It's a shame I don't get colors in here. I think if I have this in a web browser, I get these nice colors, but in this one, yeah, in this one I don't quite get the colors. And I think there's some kind of, like, some of these characters are not, like ASCII characters are not fully representable in PETSCII, so some of these characters are off from probably what they intended to have with this picture, but otherwise works pretty well. Okay. So let's take a quick peek. I'll save this. And let's take a quick peek what the total code size was. So this one. So here. Like this. Yeah, Pascal triangle is pretty tight. That's nice. I think this one did fit in an i32, so that's good like this. Yeah, I don't like this parsing. This parsing is... But there's no good way to use fscan to get a line or like stop at the end of line. So I do have to do it in a silly way like this. Oh wow. This can be an i8. i8. Sweet, okay. Like this. Yeah, no, I think that's... Can I fit this in just one line? I have this. No. Weird fascination in making this. Well, I can simplify this a little bit, but I'm not gonna bother that much further on stream. So yeah, so that's everything for today, I think. Although, yeah, well, yeah, I think that's everything that I'm gonna do now. So thanks for tuning in. If you watched this through that painful derivation of the second part, but yeah, we got through, and the code was pretty clean and nice at the end. So cool. All right, internet, take care. See you in tomorrow's puzzle. Bye.